And what I mean by that is there's an address range which just hits the SRAM. And then there's other address ranges where even though the lower half of the bus goes directly to the SRAM, when the upper bits don't address that SRAM, they need to go pick something else. So I'm guessing there's some 3 to 8 decoders in play here. I just need to figure out which ones. Enable, ground, write, 4 bits of data, more address. So basically all that's on this chip is address, data, enable, and write. So write. So this pin's right. These 4 pins are the data bus, and these are power and ground pins. And then this guy is enable. Now that we pulled these chips off, it becomes very easy to see that, hey, look, here's the enable pin. It hooks to this trace, which hooks to this enable pin. Which before would have been very difficult to see because you'd been like, okay, a trace goes in here, it comes out there. You know, you never would have been able to find this without just blindly probing all the pins. Now it looks like it goes from here as well, but I'm not getting a connection. Oops. This is a pull-up. Nope. Pull down. Nope. Oh. Okay. Here is this isolated battery-backed 5 volts coming across on this layer, and it does indeed feed both the pull-up resistors on the enable lines as well as power to these chips. So that lends more credence to the fact that just this logic here was battery backed, and we should be able to trace that guy through more thoroughly now. Goes to those 2 caps. That cap goes to that guy. This cap goes to that guy. Cap goes to that guy. This cap goes to that guy, which goes to that guy. So the only thing on this battery-backed voltage domain was these 4 chips and these 2 pull-up resistors on the enables. So now that I've traced that out and there's nothing else on it, I can go ahead and get rid of this diode, this cap, this resistor, since the only thing those 3 parts were used for was charging the batteries and supplying battery-backed power to this guy. I'll also pull this jumper just to be complete. So let's finish tracing these enables. $74.32. Excuse me. So the enable lines from the two banks of RAM, A and B, go back to the 7432. I think, is that a NAND gate? OR gate. So I'll have to do some more tracing exactly what all that goes to. But before I do that, just check a couple of the address bits to make sure. Yep. So all these chips share an address bus and go to here. The data bits we've already proven at the end of the last video, which got lost, goes through all these devices over to this driver, gets rebuffered and then driven out to all these latches. So it sort of starts right here, flows through. At some point it gets up to these devices up here. Yeah, it's just a big ugly mess. Oops. Yeah, so there's the data bus. So now where does the right pins go? So this corner pin is right. And oh, I broke that pad. Huh, interesting. So all three of these chips' rights are connected together. Ah, it's connected to here and this feeds back there. And then where else does it go? Excuse me. Hits this resistor here, goes to there, flips to this side. So this is going down that path. Hits this guy. Hits this guy. 1, 2, 3, 4, 5. So this is the end of the right path. Goes through all these to this resistor to there, and it also continues on from that resistor so this path here is the right off the processor. 2 in. So the right enable starts on this pin on the processor, goes to the expansion header, then down through all the DRAMs, the UART, and also through this resistor off to somewhere else. Now so far this is not a pull-up resistor. traced it in properly. So I think it goes to here. And it does. It may just go to this header. It's kind of odd the way they did it, if it does. Hope it does go to that header. And then it heads off. That may just be a pull-up. It is a pull-up. It's a pull-up on the battery-backed domain, which makes sense. Because they're going to want these RAMs to stay in a known state, i.e. not enabled and not write selected when power's off, because that's probably their low power state. So pull-ups, pull-up, they can all go away. A little chunk over there can go away. And I may do that quick just to get them out of the way. So this OR gate is part of the address demultiplication, or not demultiplication, demultiplexing to pick these two banks of RAM when it's their turn. So where does the other input from those OR gates go? So that's the output. So ooh, they crisscross the card. The other bank. What? The right? The right comes off this OR gate too. I'm going to have to look up that OR gate and see what's going on here. Because that was the right pin, so the enable pin for the two banks and the right pin come off that same OR gate. So input, input, output. So ground output, right? Ground output. So output, so the right is an input to the OR gate, and the output goes somewhere else. So that's right in. Chip above it. Okay, there's a 1 to 8 decoder IC. Right in 3 pins over. Okay, so an address pin from here plus right becomes this output, which then goes like halfway across the card. Okay, it vias through right there. So it comes out on the top side somewhere. So I may have to pull this chip before I find out exactly where all that signal goes. I think it's this signal right here. Nope, fail. One, two, 1, 2, 3. 1 up. 1, 4, 5. Oh, it goes all the way over to this guy. Oh, another 138. Okay. It takes the right output from this plus an address bit from this to drive one of the address inputs, or one of the 3 inputs into this 3 to 8 decoder. So this is some part of the address tree decoder logic. And it's an OR gate. Now, that's a standard OR, right? Yeah. So when either one is high, the output's high. But I think these 3 to 8s are active low. Let me check that. Go on to the truth table here. Well, they're not. Yeah, it's going to take some more digging to decode that farther. Without drawing this out in great detail, I can't tell for sure. But the basic gist of what's going on here is when this 3 to 8 decodes an address bit and the write is in the proper state, either high or low, it trips a bit into this 3 to 8 decoder to pick a new address on him. I'm guessing this might be the upper order bits for all these guys up here, but I'll have to trace it through the card some more to find out for sure. Also, that line came up and there's a via right there. So one of these lines underneath this chip coming out also connects to that pin. And short of me just sitting here poking around, it's going to be darn hard to find that guy.